Alternating current or voltage changes its magnitude and reverses its direction. Now look at this diagram. If we look here, then the polarity of the alternating current changes. First the current flow in this direction, and after flowing in this direction the polarity changes. The positive sign come here, and then from here the current start again and it flow in this direction. Now looking at its magnitude, look at here, it start from 0 and then comes to the extreme positive, then it comes to 0 again, and then again it comes to the extreme negative and then to 0. So in this case the alternating current changes its direction as well as its magnitude. So in this MCQ, option A is the correct one. Second, the mean value of sinusoidal current in one complete cycle is, where I naught is the peak value of the current. Now look at here, the mean value for sinusoidal current is 0 because the current is positive and is negative. Look at here, this one is the positive of the current. Look at here, this one is the negative. Okay, now when we find the mean value, so it will come 0, like when we add this one and this one, so we will get the 0 answer. So we say that the mean or average value of alternating current will give 0 answer. So option C is the correct one here, 0. In AC quantities, the root mean square value of the voltage is, so the root mean square value is V naught, which is the peak value, divided by under root 2. This one equation is present in your book. Okay, so here option B is the correct one. RMS is equal to V naught divided by under root 2. The sinusoidal AC voltage at any instant generated by AC generator is. Now here we know that V is equal to, where V is the instantaneous. Okay, V is equal to V naught. V naught is the peak value sine of theta. Okay, so here V is equal to V naught sine, where theta is equal to omega t. Okay, so V naught is equal to sine, omega is equal to its angular velocity. Okay, angular velocity is equal to 2 pi f. Okay, and t. So here the correct answer is V is equal to V naught sine 2 pi f t. C is the correct option. A coil of AC generator rotates with a frequency of 50 Hz. The angular speed of the coil is, so angular speed is equal to 2 pi f, where f is the frequency. Okay, so frequency is 50 Hz, so it will be 2 pi 50. So 2 multiply 50 will give 100 pi radian per second. So option C is the correct one. Sorry, option B is the correct one, 100 pi radian per second. In the graph shown, the phase change between two AC quantity is, so here is the voltage and this one is the current. So the phase change between two is the 90 degree. Look at here, when the current is at 90 degree, so the voltage is at 0. Okay, here the current is 0 and voltage is at 90 degree. So in this way they both have 90 degree phase change. The sinusoidal AC current in a circuit is I is equal to 50 sine 20t. The peak value of the current is, now look at here, I is equal to 50 sine 20t, and we know that I is equal to I naught, where I naught is the peak value sine omega t. So the peak value is I naught, so it will be equal to 50 ampere. Okay, and omega is equal to 20. So the required here is the peak value of the current. So option C is the correct here. You have to compare the basic equation and the given equation. Okay, in the above problem, the frequency of AC current is, now in above problem I is equal to I naught sine omega t, and the given was I is equal to 50 sine 20t. So by comparing these two equations, here omega is equal to 20. Okay, so we know that omega is equal to 2 pi f. Okay, and the required is the frequency. So omega is equal to 2 pi f, where f is equal to omega divided by 2 pi. Now putting the value of omega, so here 20 divided by 2 pi. Now divide the 20 by 2, so you will get frequency 10 divided by pi hertz. So option E is correct here, 10. The peak value of sinusoidal voltage in a AC circuit is 50 volt. The RMS value of voltage roughly is equal to, now V RMS is equal to V naught, which is the peak value, divided by under root 2. So V naught is 50 and under root 2. So under root 2 will give 1.41. Okay, now divide the 50 by 1.41, so you will get 35 volt. Okay, option C is the correct here. And the other method is that just divide the 1 by 1.4, you will get 0.7 answer. Okay, now multiply that 0.7 with 50, so you will get 35. Okay, so option C is the correct here. The DC current required to produce the same heating effect in a resistor as that produced by sinusoidal current of peak value 5 is roughly equal to. Now in this MCQ, the required is the DC current, and here the given is peak value of the alternating current. So we know that the current in DC, the effect of current in DC is equal to the effect of the RMS value. Okay, so IDC is equal to IRMS in case of alternating current, and the required is the current in DC. So we know that IRMS is equal to I naught, the peak value, under root 2. 5 I naught is equal to 5. Okay, so 5 divided by under root 2, this one will give 3.5 ampere. Okay, so the current in DC is equal to 3.5 ampere. In this way, you can find the DC current when the peak value of alternating current is given. Okay, here 3.5 ampere is the correct answer. An AC voltage of 6 volt maximum is connected to the 100 ohm resistor. The current and the voltage are in. Now keep one thing in your mind, that when the resistor is connected to the AC current, so in this case the current and the voltage will be in phase. Okay, so option B is the correct here. In pure capacitive AC current, the current is, now here is a trick. Okay, let's suppose civil. Okay, this is a trick here, civil. So civil means that in case of capacitor, a capacitive AC current, what will happen? The current will lead 90 degree by voltage. Okay, so this one is the trick. In case of capacitive, the current will lead 90 degree by voltage. Now look at here, the current leads V by 90 degree. Okay, option A is the correct here. Look at here, the first one will lead the second one. Okay, and you have to ignore this one I. Okay, just ignore this one, and remember that in capacitor the I leads the voltage by 90 degree, and here the option A is correct. In pure capacitive AC circuit, the instantaneous current is, now use cos theta with that one which leads the other. Look at here, for capacitor we use the trick civil. Okay, just ignore this I. Okay, so here in capacitor current leads the voltage. Okay, now here current leads, so when current leads you have to use cos theta with current. Okay, so the instantaneous current is here option C, I naught cos omega t. You have to use the cos theta with that one which leads. Okay, so option C is the correct one. Now let me tell you that in case of inductor what will happen. I told you that ignore this I. Okay, now when you ignore this I, it will be CIVL civil. Okay, so for inductor, L stands for inductor. Okay, the voltage leads the current by 90. It means that in case of inductor the voltage leads. Okay, and the current lags behind. Now look at here, use cos theta with that one which leads the other. So in case of inductor the voltage leads, so it means that you have to use the cos theta with voltage and the sin theta with current. Okay, so this one is the case of inductor. Okay, and look at this one is the case for the capacitor. Okay, so here the current leads, so use cos theta and use sin theta with voltage, and here in case of inductor use cos theta with voltage and use sin theta with the current. Okay, if the capacitance of a capacitor in AC circuit is increased 3 times of its initial value, the capacitive reactance is, now this one is the formula for the capacitive reactance. Okay, which is equal to 1 over omega C. C is the capacitance. Okay, now omega is equal to 2 pi f and C. Now look at here, when the capacitance is increased 3 times. Now when we increase the capacitance 3 times, so the capacitive reactance will decrease 3 times, because this one is inverse relation. Okay, the capacitive reactance have inverse relation with the capacitance. So when the capacitance increases 3 times, the capacitive reactance will decrease 3 times. So option C is the correct here. The capacitive reactance for DC circuit is, now look at here, the required is the DC circuit. Okay, so capacitive reactance is equal to 1 over omega C, so which is equal to 2 pi FC. Here in DC circuit the frequency is 0, so it means that the capacitive reactance will be infinite. Now look at here, this one is the DC voltage and this one is the AC voltage. Okay, in case of AC there is a cycles. Okay, and we know that frequency is the cycle per second, and in case of DC this one is a straight line. Okay, so frequency in case of DC is the 0. Now look at here, when you divide anything with 0, so it will give infinity answer. Okay, so the capacitive reactance for DC circuit is infinite. An inductor of 1 Henry opposes the flow of AC. If the inductive reactance is 500 ohm, then the frequency of AC is, now inductive reactance is equal to omega and L, where L is the inductance. Okay, omega is equal to 2 pi F and L is the inductance. Now bring this L and 2 pi here in the division. Okay, so you will get frequency is equal to XL divided by 2 pi L. So the inductive reactance is 500 ohm, 2 pi, and the inductance is 1 ohm, 1 Henry. Okay, so when you divide 500 with 2 pi, so you will get 80 Hertz answer. Okay, an inductor of 4 millihenry is connected to DC source. The inductive reactance is, now the inductive reactance is equal to 2 pi FL. Okay, in case of DC the frequency is 0, so when you multiply 0 with this term, so it will give 0 ohm. Okay, option D is the correct one. In the figure shown, resistance is equal to 3 ohm and inductive reactance is equal to 4 ohm. The impedance of the circuit is, look at here, the resistor is connected and the inductor is connected. So the formula for impedance is Z is equal to under root 3 R square plus under root L square. Okay, so R square, R is equal to 3 and L square, L is equal to 4. Now when you multiply 3 3s are 9 and 4 4s is 16. When you add these two, so you will get 25 and under root 25 is equal to 5. So the impedance of the circuit is 5 ohm. The power factor for AC circuit is cos theta. Okay, cos phi. This one is derived in your book. Okay, it is present in your book, so you look at there. Okay, in RLC AC series circuit, the VL and the VC are, now here we know that the VR is here in this direction. Okay, the current and the voltage in case of resistor is in the same direction, so the VR will get here this one. Okay, current and voltage. So and in case of capacitor, the current and the voltage, here voltage lags behind. Okay, and the current leads. Okay, so the current and the voltage here is on 90 degree, so VC will be like this and the current will be in this direction in case of capacitor. Okay, in case of inductor, what happened, the voltage leads the current. Okay, so the voltage will be here in this direction and the current will be here in this direction. Okay, so it means that the current and voltage has 90 degree, the voltage leads the current. So the required is the VL and the VC. So look at here, the VL and the VC is of 80 degree, so they are out of phase by 180 degree. Okay, 180 degree angle is present between these two. Which one of the following statement is not true for RLC circuit, AC circuit at resonance? So the phasor angle is 0, the impedance become minimum, the magnification Q factor is infinite. This one is the incorrect. Okay, because the magnification factor is not infinite when the RLC circuit is connected in a series. The current become maximum. This one is the correct one. Okay, so option C is not true. Search coils detect the metal. Option A is the correct one. In the given RLC circuit, VR is equal to 8 volt, VL is equal to 8 volt, and VC is equal to 2 volt. Okay, so the applied voltage is, now the voltage is equal to VR square plus VL minus VC square. Okay, so here VR is the 8, so 8 8s are 64. VL is the 8 minus 2, so it will give 6. Okay, so 6 6 are 36. Now 64 plus 36 is 100. Under root 100 is equal to 10 volt. So the applied voltage is the 10 volt. In the above problem, if R is equal to 3 ohm, XL is equal to 7 ohm, and XC is equal to 3 ohm, then the impedance is, now the impedance is equal to R square plus XL minus XC square. Okay, so R is equal to 3, so 3 3s are 9. XL minus XC, 7 minus 3 will give 4, for 4s are 16. So 9 plus 16 will give 25, and under root 25 is equal to 5 ohm. The impedance will be 5 ohm. Option A is the correct. In RLC series circuit, the impedance will be purely resistive if XL is equal to XC. Okay, option A is the XL is equal to XC, and this one is the correct. I'll explain this one in the next MCQ. In RLC series AC circuit, when XL is equal to XC, then the impedance is, so we know that impedance is equal to R square plus XL minus XC square. Okay, now when XL is equal to XC, so this one will cancel the XC. Okay, it will give 0 answer. So in this case the answer will be Z is equal to R. Okay, so we can say that when XL is equal to XC, the impedance is equal to purely resistance. Okay, impedance is purely resistive. So, and in this case the impedance is the minimum one. Okay, option A is the correct here. A TV inductive capacitor circuit resonates with the frequency of F0. If the capacitance of capacitor is reduced to C by 4, then the resonance frequency now will be, so F0 is equal to 1 over 2 pi under root LC. Okay, so when C is equal to C by 4, so it will give 1 over 4C. Okay, C is equal to 1 over 4C. Now put this equation here. Okay, in this place. So the new frequency will be 1 over 2 pi under root LC divided by 4. Now bring this under root 4 here. Okay, so it will be under root 4 divided by 2 pi LC. Now we know that this one is equal to F0. Okay, so instead of this term, put F0 here. Okay, so you will get 2F0 under root 4 will give 2. Okay, so the new resonance frequency will be 2 times of the original resonance frequency. The source of electromagnetic waves is oscillating charge. Option B is the correct. When charge oscillates, so it produces electromagnetic waves. In electromagnetic waves, the electric vector and the magnetic vector are perpendicular. They are on 90 degrees. The electric field intensity produced due to the rate of change of magnetic flux at a point is this one. E is equal to 1 over 2 pi r, and magnetic flux divided by time. So the electric field intensity has a formula, this one. Okay, when it is produced due to the rate of change of magnetic flux, and this one is the Maxwell equation. The magnetic field intensity at a point due to the rate of change of electric flux is, so the magnetic field intensity is U naught E naught divided by 2 pi r, where this one is the electric flux and change in time. So option B is the correct here. The rate of change of magnetic flux in a region of 100 webers per second. The electric field at a point 50 centimeter from the central region is, now the formula is here. Okay, so the magnetic flux is 100 and time is 1, and the radius is 50 centimeter, which will give 0.5 centimeter. Okay, and we know that 0.5 centimeter is equal to 1 over 2, so this one will cancel these two. Okay, and 100 divided by pi, So electric field is 100 divided by pi Newton per Coulomb. So option B is the correct here, 100 divided by pi Newton per Coulomb. The current that can arise due to the rate of change of electric flux is known as displacement current. Option A. The speed of electromagnetic waves in vacuum is given by C is equal to 1 over E naught under root E naught and mu naught. So this one is also a Maxwell equation for the speed in vacuum. Here option C is the correct.